So in the thumbnail to this video, we put that this limit either equals infinity or 3 over 2 with a question mark on it. Well, it obviously can't equal both. We're going to do three methods. The first method gives infinity, which is incorrect, and the second two methods, which are L'Hopital and Taylor series, give 3 over 2, which is correct. So let's have a look at the method which is wrong first. Okay, so what they would do is we would say, okay, well, the limit as x approaches 0, well, that's 3 sine x over x cubed minus 4 over x squared cos x add 1 over x squared. We can say that there's nothing wrong with that so far. And then we could say, well, sine x over x cubed, let's have a look at that one first. Well, that basically is equal to 3 sine x over x squared, and we know that that limit there is 3 because sine x over x approaches 1 as x approaches 0 over 0, which is approaches infinity, well, is infinite by the time we get to the limit of 0. 4 cos x over x squared, we can put in 0 there and we would get 4 over 0, which again is infinity, and then we can say 1 over x squared, right, and 1 over 0 is infinity. And then what we could say, well, we can't say, but what people do say is we got infinity minus infinity add infinity, and then somehow they think, okay, well, infinity minus infinity is 0, add infinity, well, that gives us the answer of infinity. Well, you can't add infinities up as if it was algebra. It's not like a minus a add a equals a. With infinity, you can't do that. Okay, so that's the wrong method, and that gives the wrong answer. So let's have a look at the right method now. So first of all, we're going to use Maclaurin to expand this. Okay, so I'll tell you what, let's just write it out again. So that's the limit as x approaches 0 of 3 sine x minus 4x cos x add x over x cubed. So we're going to use the Maclaurin expansion. So we're going to use the sine x Maclaurin expansion of x minus x cubed over 3 factorial add x to the 5 over 5 factorial add and cos x, which equals 1 minus x squared over 2 factorial add x to the 4 over 4 factorial So let's have a look at the top line first. 3 sine x is going to be 3 times x minus x cubed over 3 factorial add x to the 5 over 5 factorial minus 4x times cos x, which is 1 minus x squared over 2 factorial add x to the 4 over 4 factorial and then add x. Okay, and let's simplify all of this lot. That is going to give us 3x minus x cubed over 2 add x to the 5 over 40 minus 4x add 2x cubed minus x over 5, 7x to the 5 over 6 add x. That equals that, and then the 3x minus 4x add x all cancel, and that gives us 3x cubed over 2 minus 17x to the 5 over 120. That's the top line, remember, and we have to divide that by x cubed, and we want to find the limit of that as x approaches infinity. Well, that gives us the limit as x approaches 0, of the x cubed cancels there, 3 over 2 minus 17x squared over 120, add more functions of x, and obviously all of this lot approaches 0 as x approaches 0, which just gives us the answer of 3 over 2. So that is a correct method, and that gives us the right answer of 3 over 2. Okay, we're now also going to do a third method. Let's do it by L'Hopital, because that's an interesting one, L'Hopital. So basically, I'll tell you, let's go on another page and rewrite it. So we want the limit here as x approaches 0 of 3 sine x minus 4x cos x add x, and L'Hopital does seem to be the go-to method that a lot of people look at when they're looking at these limits, and there's nothing wrong with that. Okay, so let's put x equals 0 here. We have 3 times 0 minus 4 times 0 add 0. We get 0 over 0, so it's indeterminate form. Therefore, we can use L'Hopital. So we can differentiate top and bottom, and let's see what we get. Okay, well, we get 3 cos x minus 4. We're going to have to use the product rule here. Cos x minus x sine x, add 1 over differentiation on the bottom 3x squared. Now let's have a look putting x equals 0 in again, because remember every step it has to be indeterminate in order for us to continue using L'Hopital. We've already done a video on that, and that again equals 0 over 0. So again we can use L'Hopital a second time. So let's have a look what it gives us the second time. That gives us well, actually 3 cos x here minus 4 cos x gives us minus cos x. Okay, so that simplifies it simply. So now we can differentiate again. So that gives us differential of minus cos x is sine x, add 4, and again using the product rule, sine x add x cos x over 6x now. And let's have a look at that again. Sine of 0, 0, 0, and 0. Still indeterminate form. So we can use L'Hopital one more time. And this one is going to give us an answer because we're going to get rid of the x off the bottom. Okay, so that's going to be sine x add 4 sine x. Let's just write that in. That's 5 sine x add 4x cos x over 6x. Okay, and we just want to differentiate this one more time, and that will give us 5 cos x add 4, again using the product rule, cos x minus x sine x over 6 now, which equals 9 cos x minus 4x sine x over 6. And now when we put x equals 0 into this, we have 9 cos of 0 is 1, and of course 4x sine x is still going to be 0, so that's going to give us 9 over 6 is our limit, which is 3 over 2, which is the same answer that we got using the Taylor expansion. Probably in this particular instance, using the Taylor expansion is easier, I think, because you do have to keep checking that it is still indeterminate form, whereas the Taylor comes out very neatly and very nicely. In fact, you can probably do the Taylor expansion in your head. So probably use the Taylor expansion to do this. What you can't do, though, is remember, you can't just do infinity minus infinity, add infinity gives you infinity. You can't do that. So anyway, don't fall into that trap. Okay, well, I hope you found this useful. If you have, then please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.